Okay, this video is a direct follow-up of the last one I did about the self-constructing surface, and we're basically going to take this a step further. I'll show you how to create a hexagonal mesh. I'll also show you how to create scales, because that's another interesting effect. We'll talk a little bit about aligning the objects, and then how you can get any object to appear based on the proximity to those curves. And maybe if we get to it, we'll also talk about how to make surfaces, any surface, appear, and how we can combine this with things like cell fracture. This is where we left off last time with our hexagonal pattern. As soon as it's done compiling, you can see it over here. This is our hex mesh material. It's just blue, and the only change is that I have added the second setup with the instances that we created right here, just so we have them all in the same file, so we can combine them a little bit. So the first thing I wanted to bring attention to is the scale elements right here. You can see it is after the set position node, which could be an issue because you need to keep in mind that the position of the elements dictates how much everything affects them. In other words, the scale elements right here, since it is after the set position, changing the position would also affect the scaling. Okay, if you don't want that to happen, you need to swap these effects out, so you're scaling the elements before you are setting their position, just like that. And now as I change this position, they're no longer getting scaled accordingly. So definitely keep that in mind. And the same thing applies to the instancing method, where you would really want to have translation of the instances after the scaling and rotation. Alright, so that's something to keep in mind, and I'm going to probably leave it like this for now, although I don't know, maybe the other method looks better. You really have to decide on your own. So let's talk about how we can get that hexagonal mesh. It's really easy. See, if I just don't split the points, so I'm gonna mute that real quickly, or rather split the edges, and then I also don't scale the elements, so I'll mute that as well, or maybe I'll just get rid of them because we're not gonna be doing that right now. After the set position, I believe what we can do is we can go mesh to curve right here, and then we can go back into a mesh just by using the opposite node. Let me just show you what that does. Mesh to curve essentially turns our mesh into a bunch of curves, and then curve to mesh with a circle, a mesh circle profile right here. As soon as I set the radius to something, oh, that's a mesh circle, I need a curve circle, there we go. And as soon as I set the radius to something really low, 0.001, and the resolution to something low, I'll lower this one more time, and you can see how we got this hexagonal pattern by basically solidifying our curves. So what I would need to do is probably just lower the push here and maybe increase where the fall off starts, so you can get something smoother. But there we go, this is how you get that hex pattern. I'm probably going to keep this. Maybe I'll change the color just a little bit, something more less intrusive on the eyes. There we go. Okay, so if Blender doesn't crash, what? Okay. So let's continue. What I'm going to do is I'm going to just set this, this is our icospheres from last time, into here, and now we can see both of them and the mesh. However, what I don't like is that they're appearing too close together. That is because essentially they're using a very similar map, so I would just need to change these things. And more importantly, if I just reduce the incoming radius altogether with a subtract node, I can essentially, if I set this to 0, control the end of the fall off like that, so I can pull this back to something I'm more comfortable with. And at this point I would honestly combine these 4 nodes into a single one called mapping, because that's just a logical unit. So Control G to group, tab to exit the group. I will call this mapping, and now I'm going to give mapping some inputs after I remove some degenerate connection because target got duplicated. Okay, so I want the default of the trim radius. This is essentially what this value is, to be 0. So first I'll set it to 0, plug it here, rename it to trim radius, or rather rad trim, just makes more sense to me because we're reducing the radius of the point. This will be just the radius of the incoming curve. We also want the control for where the fall off starts, which would be this value. Plug that in. I will call this fall off start. And also be nice to have a control for what we're actually mapping to instead of, so we can change this, so to minimum to maximum. So if I hop out of here, that is way cleaner. And I will also change this up here where we used our topology based selection, or rather our mesh, our hexagonal mesh. So let me do that real quickly. I probably will just delete these, although just so I don't forget, I'll first connect them up. So this is the only thing, and we also need the radius, which is this thing, of course. And let me just copy these values. So this would be our fall off start. The trim has to be 0. This should be the mapping. And however, we're outputting a lot of things here, like the distance and the attribute. We don't really want to be outputting those. So I'll remove this. All we want here is the result, which is essentially our map. And the reason this disappeared is because we were using that to control the less than, which used the selection for instances. So I will plug that in again, and this time I'll need a threshold that is set to, I think it was greater than something very close to 1, but not quite 1. Okay, might have been less than for the instances. There we go. So that's brought us back to where we were. And again, over here I will plug this mapping node to where it needs to go, which is just really just over here, because I'm really only setting the position, but also it is controlling this node right here, which again we will change to just be 0.999 and either greater than or less than. It depends on which method you're using. So then I should be able to just trash these, and now we have our mapping node which we can control more intuitively. For example, I now know that this just trims my radius, this just trims where the fall off begins, and it's on a single node. Alright, so that helps out. What else can we do? I would, at this point we have still a lot of nodes, so I would group them into more logical units. For example, I know that all of this is responsible for the hexagonal mesh, so I'll group these. I will hop out of here to the very last, and I'll rename this to hex mesh, because that is essentially what it is. And all of this, which controls the icospheres group, again I'll just rename this to ico. Move it up. Probably, yep, there are some degenerate connections here. I will fix these real quickly. For example, there is no point in having two targets. There we go. This is my tangent. I can probably rename this. I can also split this up, which is just some of the bonuses to being able to group things, to grouping things. Now I can have less stretching going on here. Okay, so that's great. What have I muted here? The scaling. We'll probably get rid of the scaling for now. Do note that you can use it. Yep, let's just have all of that. And there we go. That is much cleaner. And everything is grouped into these logical units. So, let's talk about something else. Let's talk about the scales. So how do I actually do the scales? The scales are pretty simple. So instead of using an icosphere to instance on the surface, I have made a little model over here. It is sort of a scale, kind of, very simple. You can do a better job. But basically, I will bring that into my icospheres, which I will rename to scales. And I will, instead of instancing icospheres, I'll just take object info. And we want this one to be original, because we don't want transformations to the scale to actually affect it. This is just going to be an instance. Plug that into instance, and then also select my object, which would be scale. And now it should work. There we go. We have our scales. Now the scales are aligned improperly. I'll just switch that to Y, and I'll probably hide the hexagonal mesh. It's sort of in the way, really quickly, just so we can focus up. So scales are really tilted up a little bit. So before I actually do anything here, I will run my object that I'm instancing to a transform node, which I will rotate on, I think it's the X. There we go. So the X rotates these up. That's pretty good. However, this is still not how scales work. They're sort of intertwining. To do that, it is not that complicated. We just need to instance a second set of points. However, these ones we will instance on a dual meshed version of our model. Remember, the dual mesh swaps faces with vertices. So essentially, you see what happens if I plug that in here, this into the points. But also keep in mind, we need the exact same rotation, the exact same scaling, and the exact same selection. So over here, plug these in and just join these instances afterwards. I should see. There we go. So now they're intertwining. They're in this pattern which scales usually have. You could use this transform to just change them a little bit. I would honestly scale them on the Y, I believe. Make them a bit sharper. There we go. Maybe reduce the rotation a little bit. At this point you can have a lot of fun with that. However, do mind, the scales are aligned based on the tangent of the curve underneath. Remember that. So what that means is, because I have a curve going like this, it has an axis on which to align them. Which means that the scales which are way over here, for example, are still aligned sort of improperly now. And to fix that, I would just need to take the last point of my curve and expand it downwards. So that essentially, you know, we have this curve going like that. And also what this means, that if I take this curve, for example, or rather, by the way, you can change the radius of the curve with Alt S. So if I scale this up so it encompasses the head, you can see all of them have this alignment, which is still the direction of my curve. And if you don't want that, you just need to, well, let me change the radius again. Press E to extrude that curve and extrude it up until it's in the head. And now, since my curve is going like this, you will see that all of these scales are essentially aligned differently. To be more correct, they're aligned with the underlying tangent. So do keep that in mind. If that is not what you want for the curve to control the alignment, you can just remove this node, which is aligning it with the tangent. Or if you just disconnect this and you set it to Z up, it will align them with the world up. So this might look fine on surfaces that are already aligned up, like the arm, but if I just come over here, you see that these are now going upwards, whereas if I connect it, they're going around the length of the arm. It really depends on what you want and what you're satisfied with, but I'm just giving you both of these methods and I'm explaining a little bit. Now, a big issue that I had is that I cannot see my curve anymore. It's covered, it is now the geometry. Even if I bring it up at the end, it still won't be that visible. A quick solution for this is, I'm going to take my Bezier curve in the outliner, and then in the viewport I'm going to press Shift D and then press the left mouse button. I'll make sure I haven't moved it, so type move 0, and then I'll click linked. So linked means that everything that is inside the object data properties, including everything that is inside edit mode, is now linked. However, the modifiers are not linked, so I can trash all of these modifiers and rename the second curve to something like curve outline. And now I can give this curve outline its own modifier, its own geometry nodes, and this will be a very simple geometry nodes, which will just turn it into a mesh. So curve to mesh, and I will use a curve circle. So here we go, curve circle, we plug that in. We definitely don't want the radius to dictate the depth here, or rather the cross-section width. So to do that, I will just set radius, set curve radius, and set it to a constant value of something like 1. However, that is way too much, so 0.01 is more like it. And then I also change the resolution to something like 6, really doesn't have to be more than that. And now we can sort of see the outline. But if we go into the object properties, which are still unique per object, unlike the data, I can check in front of, right in the viewport display. Also, you would need to be inside the viewport shading in order to view this, because this is viewport display after all, and I checked in front of, and now I can see my curve in front of all the geometry, but it doesn't work in the other modes like EV or cycles. But now I can see my curve, and any transformation done to this curve is applied to the original one, and vice versa, because I have linked their object data properties. What else you can do in here is you can also instance on points, and on the points of my curve I will just instance an icosphere. You see what that does in a moment. I would need to join these two geometries, of course, just like that, and reduce the radius. And now I can also see the joints. Maybe increase this a little bit. You can also go fancy, set shade smooth to hide the fact that it's an icosphere. Of course, check that on. And now I can see where my vertices are. I can just, in my Bezier, it doesn't matter, just extrude them. And this is important because, as I said, this line here determines, I'm pressing R to rotate, the alignment of our scales. So do keep that in mind. But now we can see them a little bit better. And this is honestly to taste, so knock yourselves out. Maybe I'll reduce the radius a little bit. It's a bit too overwhelming. Okay, that's too small. This is fine. Alright, so that's how we can still view our curve. I'll go back to this one, which has our two node networks, and let's talk about what else we can do in terms of fancy effects. So we can actually, if I focus back on our hex mesh and go back into rendered mode, you can see that our hex mesh is coming out of thin air. If I grab my curve here and Alt S to scale it, as soon as I'm in edit mode, it's sort of popping into existence. I want it to appear like sort of thin air, like out of energy, I suppose. And the fun thing is that you can actually embed information about the proximity of this geometry to the curve into the geometry itself. To do that, we will go back into hex mesh, and right in here I will use capture attribute to actually store information inside this geometry. What I'm going to store is a map, this map, and I want a unique map, so I'll just shift D, this thing. And remember, this is just map based on the radius to the curve. I'll plug this into the values I want to store. I'll plug this out, maybe rename it to prox. And I also now I need to plug this to the final group output of my geometry nodes. I will title this something like hex mesh proximity. There we go. So now in order to bring this information into my shader, I will go into the shading node, and this is just the hex mesh material I gave to my mesh, and I will bring it in with the attribute node. Now the name here actually depends on what I type inside the modifiers. This is my geometry node modifiers, and you can see hex mesh prox. I can give it a name. I'll just give it the exact same name. I will copy that and I will paste that over here. And now if I just put that into surface directly, just so we can showcase the effect, you can notice now we have this map that is in our shader editor and that we can use however we like. And the good thing is, if I plug this map into alpha, now what you're going to see, however, if I am using Eevee, just make sure that your render property is set to Eevee. Go to the material, at the very bottom you will see settings. You want blend mode to be alpha hashed. There we go. So the first thing I'm noticing is that my map is flipped. I could flip it in here, but I have more control in it over here. So hop back into geometry nodes, hex mesh, and just swap the minimum and maximum. And from here I can also sharpen out this transition by changing off the fallout start, something like that. And that looks pretty cool. And now you can see how my mesh is appearing out of thin air, which is pretty cool. One more thing, we can hook this up to some emission simply by just plugging it into there. Make sure that in your render properties you have bloom enabled right here, because otherwise you won't see the glow. For Cycles it has to be a post-processing effect, but yeah. So I'll give it a pretty neat color, something that I'm comfortable with. I'll set the default emission to 0, and then I'll just plug this factor into emission. And now we should see that, well, the entirety of it is glowing. So what I would probably need to do is flip this map with a matte node. Let me try that. So subtract. We just subtracted from 1 to flip the map. And then it will also need another matte node for a boost, in order for us to boost this value. And there we go. How about that? You can now just see how it's glowing at the ends. The stronger it is, the more it glows. I would also recommend at this point, you can boost the glow from intensity over here if you so desired. However, do be aware of that will probably blur everything else up. Another thing that helps here is to run this through power, just so we can taper that off more smoothly. So power of something like 2. And I just think that makes the transition even smoother, but that's pretty cool if you ask me. Now we have successfully linked our radius to everything else. Let's reset the intensity. It's kind of overbearing right now. And there we go, now it's glowing at the end, so we can taper that off even more. And that's a pretty cool effect. So let's get back to geometry nodes. Let's bring ahead, let's go ahead and bring, where am I right now? Geometry nodes of this curve. I do get a little lost here. Let's go ahead and join these up, so I can see my scales again. So I won't see my scales because they have the same material, and at the point where the scales are, the material is invisible. So I will just change the material by adding a new one to my curve. I will call this scales. Let's go ahead and make scales be something, again, bluish, maybe purplish. Have fun with it. I'll plug this in here. Okay, that is kind of fancy. That's a bit... Okay, I'll pump up the metallic. I'm not really going for anything in particular here. Again, my scales are appearing way too close now. To fix that, I'll just hop into the mapping node and I will change the trim, which will push them all back, which will push them back all together. Very gently though, very gently. And I don't really want this sine effect anymore, so I'll probably trash anything related to it. I really only want to rotate the scales now, but this is entirely up to you. So everything that doesn't have to do with the rotation goes bye-bye. And you can see now I'm rotating them as they are coming in. And if I change this to pi, which is 180 degrees, we can see that now we are getting this, as soon as I go into edit mode, this effect where they are flipping out of the ground. So this is like the mystique effect. If I actually give it more direction here, you can see, yeah, the mystique from X-Men effect. Now we've combined them. Yeah, that's pretty cool. That's pretty cool. Again, do keep in mind that the tangent determines the orientation of the scales. That is so good so far. Let's talk about getting some more complex geometry to behave similarly. So I went ahead and I made some armor. Now it's not that great, but it is just here to prove a point. I'll go ahead and hide that. I have it all in a collection. I will bring this collection into my geometry nodes. If I hop out of here and I just go collection info, make sure it's relative in this case, and all I would really need to do is get the mapping node. Yeah, there we go, and give it the appropriate information, which is the target. It is also the radius, and I'm basically going to again embed the distance from the curve into the geometry. So we would need to use a join geometry here, and I would need to pass this through a capture attribute. There we go, capture that as an attribute, and I will need to plug this out at the very end, and this will be the information for the armor prox, the armor's proximity to the curve. I will give it some material. Let's go ahead and plug that material into our curve. I will call this one just armor. There we go. Something bluish. Again, that's the theme we're going for. A lot of people told me I'm just making Pepsi Man, but that's fine. I like Pepsi Man. I don't drink Pepsi, but you know, that's fine by me. And at this point I can hop into this material in my shading. There it is. And again, attribute, again I have to rename my attribute. I'll just call it the same thing, armor prox. Copy that, paste it into here, double check that it does work into the surface. I do need to flip it, I think. So I will flip this map just like that. Oh yes, of course, I keep forgetting this. The collection info spits out instances. I know, it's pretty deceptive that it says geometry, but nope, it actually gives you instances, which means you need to realize these instances. There we go. This is something that definitely needs to be changed. But yeah, if I hop back into shading, you can now see that it's showing up. If I select a vertex, Alt S, you can see, again, we can see that in our shader. And let's just do the same thing we did last time, where the factor goes through a math node to flip it. Subtract 1, and that would just be our alpha. Put that into here. What we're going to see in a second is that indeed, however, I think I'm seeing the original armor underneath. Or rather, I didn't actually set up armor. In the bottom needs to be, like I said, blend mode alpha hashed. Definitely, and there we go. Now it's actually working the way we want. However, it doesn't look like I actually need to flip this one. There we go. So now my curve controls the visibility of my more complex geometry as well. I guess we can go ahead and do the glowing effect. I'll show you a cool way to do that in this case. So using a Voronoi. So if I take this Voronoi and I just multiply it by this factor, right? What we're going to get, come on, work with me, is essentially embed the Voronoi into our surface. So it's all over the place right now. I'll probably give it very fine scale, like 100. If I zoom in quite a bit, you're going to see it, but it's all over the model. To do that, I'm just going to overwhelm, basically, the Voronoi texture wherever this texture is equal to 1. To do that, I'll just sum them up and clamp this result, which will just limit this effect to the boundary. There we go. And now to make this effect more visible, what I can do is use a matte node that is set to greater than, which will give us a pretty sharp cutoff at this point. There we go. Now we are truly seeing our geometry get generated. Now for an even cooler effect, you can set this up to distance to edge, which gives sharper pieces, I believe. There we go. Now we can sort of see how we're constructing our armor out of thin air. And what I really think sells this effect is if you give it a little bit of a glow. So another matte node. What I'm going to take in this case is, I guess, this mask. However, I would need to flip it, I think. So subtract from 1, that's going to be the emission strength, the emission color. Again, something bluish, that's the theme we're going for. And I will plug this through a matte node in order to boost it up as much as I would like. As soon as it's done compiling, give it that sweet boost. I think this needs to be before the greater than, something like that. Of course, not quite like that. Let's see. Yeah, there we go. There we go. Now we have that glow at the edges. However, I like to pass this through a power so that we get a smoother transition. Probably something high, 4. And now I can really bump that up, and there we go. Alright, how cool is that? How cool is that? And now we're sort of building armor. And honestly, if you have any experience with the shader editor, at this point, as long as you have the 0 to 1 map at the edge, you can do whatever you want here. I'm just giving you examples. I just think I have pretty much found this effect by accident, so definitely play around with it, just like I did. Currently, if I just delete this vertex, we can see this from a bigger range. How about that? I do like that. However, I'm noticing that over here my edges are not glowing or appearing the way they should. This is probably because I need to just drag a point here. Essentially, it's important to have points because these points, remember, it uses the closest point. So if it latches onto a point that is not correct, instead of this one, it won't actually work correctly. The whole effect pretty much. So just make sure that you have your geometry set up correctly. You can also adjust the edge here if you don't think it's fading out enough. Again, we'll do that by just controlling the hex mesh. And the way we capture this attribute, this fall off would increase where the blinking starts, and that can sort of hide any issues we get there. You can also have these scales coming up from underneath at the end. I already showed you how to do that with the instances. And really, I don't know what else to tell you, because what else do you want? How much more stuff do you need? So this is a different scene. What I have here is just a monkey, a cube, or a stretched out rectangle, I guess, and a flat plane. So what I'm going to do is I'm going to use self-fracture to show you some things here. Let's go ahead and go into the particle system, add a particle system, set the frame end to 1 so it spawns all particles immediately. And I guess this is a fine amount of particles, although do make them emit from the volume. Shift Z will help me see that. And now I will just go into edit preferences. In my add-ons I will enable self-fracture. Oh, it's already enabled for me. Go ahead and check that. And then object, quick effect, self-fracture. Now make sure source limit is 0, so it's using all the particles. Margin should be 0. You can see it has a little value here by default. Neglect that. And give it a collection, so chunks, for example. And show progress through time off. That just speeds this up a bit. And let's see how long this will take. Okay, that didn't take too long. I'm going to hide the collection of chunks and probably delete the original cube. I don't really need it anymore. If I had the viewport, you can see these are very close together. And let's just go ahead and put the monkey there just for fun. Alright, so if I then create another Bezier curve, let me just get one Bezier curve. I go into edit mode and I shift it somewhere over here for no reason whatsoever. Foreshadowing, I suppose. There we go. I don't want it to be this junk. I'll move the handles a little bit. And after that, if I hop into the geometry nodes, I can give it the same node as before. First of all, give it a new node, and I will give it the, what did I actually call this? Self-construction. Although I will press this to copy this. So I have now copied self-construction. And instead of doing all of this, I'll trash these nodes. I'll probably trash all these nodes as well. And collection, I'll change this collection to be the chunks collection. I will also make sure I have checked separate children. Now I can use the exact techniques I used before to make something like a bunch of objects behave very much like the instances we created, and that's really what I'm trying to showcase here. So for example, if I do translate instances, because remember this does not output geometry, it outputs instances. And that's transfer attribute. I want to translate instances. There we go. And then I also make sure that I use the mapping node that we created, give it the appropriate information again, like the radius and stuff. And I plug that into a translation, which I will also control with a multiply. Oh, and the problem is that I'm not actually outputting this. So group output in this case does not need these things, and I'll output these instances. However, I will hide the original ones. There we go. So currently you can see that my curve, the radius, controls this weird effect currently because, well, first of all, I'm translating them on all axes. That's not really what I want. For example, I just want them to go on the Z. Although they do seem to be... see, they're going a diagonal because it's going in X, Y, and Z. So definitely plug this through a combine X, Y, Z. And I only want to affect the Z in this case. And I just do scale instances right after this. And I scale with the reverse of this map. We already did this last time. I'm basically repeating the steps we did for the instancing. And plug that into scale. We should get a pretty interesting effect. Yes, like I said, you need to translate after you scale, because it affects how the radius affects other things. And now we can see that we're building a surface up from above. Similarly, and how high up the pieces come from can be controlled with this multiple value. Alright, and of course you can again add the glow effect like we did last time. I'm not gonna go over it again because it's the exact same thing here. So this is another way to construct a surface. You can have them rotating again before the translation. Rotate instances, and you can use something more particular, or I can just use a random value, which would be a vector, and I would need to set this to -1 just so it goes in every direction. And then I will just align this rotation with that random rotation, and what I'm going to be controlling with the map is this factor. And now as I increase it, you can see they are indeed rotating randomly, or rather they're coming in from a random rotation. I guess I can soften up this effect by increasing the fall off. There we go. How about that? This is really what I wanted to show you. Now constructing a flat surface. And of course, this is why I put the monkey here, just to show you that this works with anything. I can put in a monkey here. There we go. But again, this is a self-constructing surface that you can control with curves. And really, what more else do you want? Now you can recreate this exact effect on the human model. I just thought it would be simpler to see it here. What you did then is just give it a solidify modifier, so that you can create a shell of chunks around him. Special thanks to Skibibble the Fox. Special thanks for emotional support, I suppose. Goodbye.